Hey guys, welcome to my crash course. This is Varun here, and I'm going to be talking about cancer. The word cancer brings many raw emotions to people. Though cancer in various forms has been known for thousands of years, the advances in genetics and virology over the past many decades have changed our understanding and focus for treatment of this disease. The genetic and virologic component of cancer has created a remarkable new paradigm from which to understand, treat, and prevent this often all-consuming disease. The Gale Encyclopedia of Science describes the naming of the disease by Hippocrates in 400 BCE, due to the veins emanating from a breast cancer, quote, resembled the legs of a crab. Hence it is called carcinoma in Greek and cancer in Latin. Later, in the mid-1800s, German scientist Rudolf Virchow postulated that cells in the body could overgrow in number, or become hyperplastic, and thus produce the characteristic masses seen in cancer. Cancer cells become hyperplastic and produce tumors, which can also seed other areas of the body, or metastasize, and create other tumors distant from the original tumor. This ability of cancer cells to move throughout the body is called metastasis. As outlined in the National Institute of Health page on metastatic cancer, cancer cells spread by invading nearby normal tissue, moving through walls of nearby lymph nodes or blood vessels, traveling through the lymphatic system and bloodstream, stopping at a distant location, invading blood vessel walls, and moving into the surrounding tissues. This is why early treatment of cancer is focused upon finding the cancer and removing it surgically so as not to allow it to grow or go to other locations. However, as it was found that some tumors could be removed but some of the cells had already migrated to other tissues before the obvious tumor could be removed, the surgical techniques became more and more radical, requiring larger and larger amounts of tissue removal. Slowly, medications and radiation therapy became available to be able to treat the cancer cells throughout the body, as opposed to just at the site of the tumor. The surgeries, chemotherapy, and radiotherapy addressed the cancer already present, but over the 1960s to 1990s, research was being done to elucidate the underlying mechanisms of, of developing cancer in the first place. The Gale Encyclopedia of Science highlights that in the 1966 Nobel Prize given to Francis Peyton Rose, who was able to isolate a virus from cancers in chickens, then infect healthy chickens and produce the same cancer, creating the knowledge of how viruses can cause cancer. Additionally, findings of families who are prone to have various cancers across generations highlighted the genetic and hereditary nature of some cancers. In 1982, three different labs identified a gene called RAS, which in cancer cells was mutated from the normal RAS gene in non-cancerous cells, and would cause abnormal hyperplasia, unbridled growth of those cells. These genes were then called oncogenes. Later, in 1986, some of the same researchers found another genetic mutation in cancer cells, where a gene which helped to slow the growth of cells, or is also called a suppressor gene, was mutated in a way it would not work. It has since been found that the majority of cancers will have some combination of mutations in oncogenes and suppressor genes, which together cause the majority of cancers. We now have vaccines which can be given to adults and adolescents to prevent many cancers in their future by eliminating the viruses from being able to infect those who are vaccinated. Additionally, we now have genetic therapies targeting the mutated genes to help them function more normally and thus treat the cancer in a more targeted fashion. These treatments are often without as much side effects of surgery, chemo, or radiotherapy. It is an exciting time in the management of cancer, with genetics and sophisticated analyses leading to more targeted treatments for different patients, even with similar cancers. Thank you. Thank you, guys.